Hi guys, hope everybody is coping well. So in this second session, we are going to cover the more interesting part of statics. I like it, which is the force vector. Okay, we will focus on the two-dimensional part of the force vector as shown on the slide here. Okay, so stay tuned. Before we proceed further on the calculation part of statics, it is very important for us to differentiate between a scalar quantity and a vector quantity. What is the difference? Why is it so important? Okay, number one, scalar quantity is defined by its magnitude only. For example, the measurement of length. Okay, take the example of this ruler. The length of this ruler is say 25 centimeter. So at any direction I look at it, like this or like this or like this, it will always be 25 centimeter and it will not magically change to become 30 centimeter instead or 100 centimeter. We are not living in Hogwarts, for God's sake. So a quantity defined by only its magnitude is categorized as the scalar quantity. Vector, on the other hand, is defined by its magnitude and also its direction. An example of vector quantity is the tension force of the cable. For example, this is my cable, and the corresponding force of this cable depends on the direction of the cable, as in the angular distance of this cable. Maybe in this direction of 0 degree orientation, maybe the force is lower, but if I change the direction, increase the angular displacement to be 45 degree, then probably the corresponding tension force is higher. So unlike a scalar quantity, direction is a very important characteristics for a vector quantity. Okay, so vector, again, I would like to emphasize, it is defined by not only the magnitude but also the direction of the vector. I love to use the example of a hanging Spider-Man in illustrating the concept of vector. Let's say if we want to measure the tension force of the spider web, we know that force is a kind of vector. So we can draw an arrow to represent the force vector. Notice that arrow have an arrowhead because vector is defined by its magnitude and also its direction. So the magnitude of the vector can be represented in normal font like this. The vector, on the other hand, is commonly represented by a bolded font. Tapi when you are writing that on a paper, it's difficult to draw the bold font and differentiate it with a normal font. So the vector can also be represented with an arrow on top of its symbol. Okay, remember vector is influenced by its direction. So the angle measurement is important to define the direction of the vector. The angle is always measured from the positive x direction. Okay, then we will draw the angular direction in counterclockwise manner. Remember, counterclockwise manner. And ta-da! That is how you define and illustrate the vector quantity. Just like in any mathematical expression, the vector quantity can be multiplied, divided, added or subtracted. Okay, tambah tolak, darab bahagi, that kind of thing. But the operation always have to consider the direction of the vector. Okay, if we multiply the vector with a scalar quantity, the vector will either have a lower or higher magnitude in either the same or different opposite direction. So let's use the same spider web example. If vector A is multiplied with 2, remember 2 is a scalar unit, okay, then the corresponding vector would be 2A, meaning the magnitude becomes twice higher or twice longer compared to the original vector. If vector A is multiplied with negative 1, then the corresponding vector would be negative A, meaning the magnitude of the vector still remains the same, tapi sebab dia negative, the direction becomes terbalik, becomes opposite direction. Okay, accordingly, if we divide the vector into half, then ada negative symbol lagi, so the magnitude of the corresponding vector is shortened by half. Again, sebab ada negative, then it becomes the opposite direction compared to the original vector. See, senang je kan? Okay, the second mathematical operation related to vector is vector addition, penambahan. What is so special about adding vector is you cannot simply add vector quantities similar like adding scalar quantity. It's not like 2 plus 2 equals 4 kind of solution. You have to remember that vector is a quantity which is also defined by its direction. So, in order to solve vector addition, you need to use either the parallelogram method or the triangle method. I am going to use the same spiderweb example in this case. Only this time around, our spider have shoot out the net at 2 different directions and you need to calculate the resultant force. Let's call the force vector to be A and B. If I remove the spider, this is how the vector looks like. Okay, the first step in forming the parallelogram shape is that you have to join the tails of the arrow of the vector. Okay, the tails, not the arrowhead, the tails. Then, when you have joined it at the tails, you project each vector to the opposite side until it meets up with the arrowhead of another vector. Make sure the magnitude and direction of the vector remains the same as the original vector. Similarly, you duplicate and project another vector, which is vector B, to the opposite side. Now, you have formed a parallelogram shape. You see, it's a parallel shape. If you connect the tail to the arrowhead diagonally across the parallelogram, that line would be the resultant force of vector A and B. And we'll call the resultant force to be R. Okay, make sure the direction of R is from the tail of the two vectors to the arrowhead of both vectors. Okay, that R is actually the addition of vector A and B. And we can rewrite it like this. Tada! Dah siap! Now, similar concept applies when you want to use the triangle rule instead. It's actually the same thing with the parallelogram law. Again, we have two vectors of A and B. So, instead of joining the vectors from its tail to another tail, this time around, I will connect both vector from the head of vector A to the tail of vector B instead. Okay, from there onwards, I just connect the tail of vector A to the head of vector B to form the resultant vector line. Actually, if you look at it, it's actually half part of the parallelogram shape. Okay, similarly, you have to ensure the direction of the resultant vector is from the tail to the head. So again, the resultant force, which is R, is equal to A plus B, which has the same magnitude and direction as the one that you get from the parallelogram law. Now that we have constructed the resultant vector between two individual vectors, the next step is you can actually calculate the magnitude and direction of the resultant vector using either the cosine law or the sine law. Using the cosine law formula, it should look very familiar to you. You can calculate the magnitude of the resultant vector of R using this equation, which is the square root of A squared plus B squared minus 2AB cos gamma. Okay, notice that the expression used in this equation are all magnitudes. It's not direction, it's all magnitudes. We will look at the example later. Okay. Other parameter in the vector can also be calculated using the sine law, which stated that magnitude of A divided with sine alpha is equals to magnitude of vector B divided with sine beta. And that is also equivalent to the magnitude of R divided with sine gamma. Okay, again notice that all the variables used in both of these equations uses only the magnitude of the vector. Tak ada simbol arrow ya dekat atas each expression. They use a normal font. So it means it represent a magnitude vector, just a measurement sahaja. Okay? Okay, let's look at this example. In this example, given that the hook is subjected to two forces, and we call the two forces to be A and B. The magnitude of force A is 150 Newton, and the magnitude of force B is 100 Newton. So in this question, they want us to calculate what is the magnitude and direction of the resultant force, R. The first step is you have to construct the parallelogram diagram that sounds funny, so that you can estimate where is the position or direction of your resultant vector. So this is how my parallel diagram looks like, and the resultant force would be a diagonal line crossing from the tail to the head of both vectors. Okay, now look carefully at this example. Okay, we can calculate this angle over here, whereby we know that it is a 90-degree angle between the x and y axis, and then we subtract with 10 degree and 15 degree angles, so the remaining angle would be 65 degrees. So for a parallelogram figure, 65 degree over here would be equal to 65 degree on the opposite side as well. Okay, now can we calculate the angle over here? Yes, of course. We know the angle of the internal shape will always be equal to 360 degrees. So we can calculate the angle at 360 degree minus 65, and then there's another 65 degree over here, and then we know the angle at the opposite side is the same to one another because this is a parallelogram. So we just divide it with 2, and you will get the angle over here to be 115 degrees. Okay, so now I want to simplify this parallel diagram into an equivalent triangular diagram so that it's easier for me to illustrate and apply the cosine and sine law. Okay, so I'm redrawing the vector A and vector B, and I know vector R is crossing from the tail of vector A to vector B. Okay, we know the angle between vector A and vector B is 150 degrees as calculated earlier. So now our triangle diagram is complete. You can actually calculate the magnitude of R and also the direction of the resultant force using the cosine and sine law. Okay, first, using the cosine law, we know that R is equivalent to A squared plus B squared minus 2AB cos 115 degrees, and square root all the values. Okay, we know A is 150 Newton, and we know that B is 100 Newton. So we substitute the known value in our equation, and we will get a final answer of resultant force to be 212.55. What is the unit? Unit is Newton lah, because A is in Newton, B is in Newton. So by right, the resultant force should also be in Newton. Okay, so now you already got the magnitude of resultant force. Okay, the next step is we can calculate the direction of the resultant force by using the sine law. Okay, let's call the angle over here to be alpha. Okay, so using the sine law, we can calculate B divided with sine alpha should be equal to the magnitude of R divided with sine 115 degree. Okay, using basic mathematical operation, we can rearrange the equation so that we can calculate the value of angle alpha. Since B is already known, the magnitude of R is also known, so we can easily calculate alpha using our calculator, and we'll get a value of 25.2391 degrees. Is that the angle that we want? No, not really. We want to know what is the angle of the resultant force, which is theta. Okay, now we know that the angle between x-axis and y-axis is definitely 90 degree. And then we know the angle on the upper part is 10 degrees. And you already calculated the angle of alpha. So we can easily obtain the value of theta by subtracting 90 degree minus 10 degree minus the alpha degree that we calculated earlier. Okay, just use your calculator and you will get the value of theta, or the angle of the resultant force, to be 54.76 degrees from the x-axis. Okay, dah siap. as I have shown you previously, you can easily construct the resultant force between two vectors using either the parallelogram law or the triangle law. Usually, the resultant force will always be located in between the two individual forces, and direction is always from the tail to the arrowhead. But what if you have to deal with more than two vectors, like this case? There are four individual vectors that you need to consider, which is A, B, C, and D. How do you know which is the direction of the resultant force of these four individual vectors? How do you even construct the parallel diagram or the triangular shape? Sudah. Pening dah kan? Don't worry, all is well, all is well. So in this case, it is more convenient for you to split each vector components into two planar direction, which is along the x and y axis. Let's take vector A for example. We can split vector A into x and y component. If we draw the boundary parallel to x and y direction, then the vector A in x direction will look like this, and we call it the AX vector. Then the vector of A in y direction will look like this, and let's call it the AY vector. Now, this looks like a parallel diagram kan? It should look very familiar. So if we apply the vector addition equation, vector A is actually equivalent to vector AX plus with vector AY. Okay, can we calculate the magnitude of each component vectors? If you notice, the shape of this vector is like an ideal triangular shape with 90-degree corners. So, you remember kalau 90-degree corner tu, you boleh pakai the sine, cos and tangent law. Okay, we can solve this using common trigonometry equation. Okay, let's say the angle between the x-axis and also vector A to be theta. So we can calculate AX to be A cos theta. Okay, remember cos tu dia relate dengan line di sebelah dia kan. So that's why you tengok AX is next to the angle theta. So that's why the relationship is A cos theta. AY can also be calculated using the sine equation pula, by which AY is equivalent to A sine theta. So notice the position or the location of vector AY is at the opposite of the theta angle. So that's why kita pakai sine. Okay, now let's recall some of the fundamental in your physics or mathematics class back then. Okay, any vector direction along the x-axis can be resolved into I hat, okay, while the vector along the y-axis can be resolved into j hat direction. So the I hat and the j hat that we use is actually Cartesian vector notation. So vector A can also be rewritten as magnitude AX along the I direction plus with magnitude AY along the J direction. So you notice the Cartesian equation is in vector form. Vector form sebab apa? Sebab atas simbol A tu dia ada arrow dekat atas tu. So bila ada arrow tu meaning that is a vector quantity. Okay, this equation is a vector quantity sebab dekat dalam equation tu ada dua benda, which is the magnitude of the vector, which is magnitude AX and AY, and also another parameter which is the direction of each vector, which is it is defined in direction I and direction J, ataupun dalam erti kata lain it is defined in direction X and direction Y. So that is why that equation is actually a kind of vector. Okay, now let's look at this example. In this example, you given two vector with different direction, which is vector A and vector B, and you are required to calculate the resultant force between vector A and vector B. Sekarang ni of course lah, you sebab ada dua vector, you can use a parallelogram ataupun triangle. Tapi for this example, I want to show you how you can solve it using coplanar forces. Okay, first we split the vector A into two component, which is in x direction, or we call it AX, and also in the y direction, and we call it AY. Okay, magnitude AX can be calculated by using the formula of A cos theta. So A is 50 Newton, cos theta, theta is 30 degree. Use your calculator and you will get the magnitude of AX to be 43.3013 Newton. Okay, now you can also calculate the magnitude of AY using formula A sine 30 degrees. So A is 50, use your calculator and you will get the magnitude of AY to be 25 Newton. Okay, A dah settle. Now similarly, you have to split vector B into BX and also BY. Okay, in BX, we know the formula is B cos the angle over here, which is 20 degree. So our B is 30 Newton multiplied with cos 20, and you will get a value of BX to be 28.1908 Newton. Okay, now solving for B in the y direction pula. So BY is equals to B sine 20 degree. So our B is 30 and sine multiplied with sine 20 and you will get the magnitude of BY to be 10.2606 Newton. Now notice that both vector has been resolved into direction X and direction Y. Using the same principle, the resultant vector between vector A and B is the summation ataupun addition of vector A and vector B. Okay, if we rewrite vector A in its Cartesian vector notation, it will become AXI hat plus AYJ hat. Okay, and then we also rewrite vector B into an equivalent Cartesian vector and it will become BXI hat plus BYJ hat. Okay, sekarang ni your parameter is defined into only two direction, which is direction I hat and also direction J hat. So you boleh solvekan dia according to each direction. So let's solve for the I hat first. So for the I hat, AX plus BX multiplied with the I hat direction. And then if you want to solve for the J hat, kita ambil magnitude daripada J tu saja, which is AY plus BY. And then letak dekat sebelah kanan dia J hat to indicate that that magnitude is for the J direction. All this magnitude, AX, BX and also AY, BY, kita dah kira tadi kan? So you just substitute that value into your equation. Okay, please notice that for the BX, kita letak value negative 28.1908. Kenapa negatif? Kenapa tak kita total up je semua magnitude? Okay, ingat vector ni is defined by its direction. So you tengok direction of the BX tu dia ke kanan ke kiri? Dia ke kiri kan? So anything towards the left would be negative value. It's along the negative X direction. So that is why the BX is being represented as negative 28.1908. So next time when you're solving for this kind of equation, please take note on the direction of the vector. Untuk magnitude along the y direction, it's quite straightforward sebab both direction is in the positive y direction. So that is why you just remain the magnitude to be positive. Okay, if you total up this value, you will get the magnitude of 15.1105 along the I direction and 35.2606 along the J direction. Okay, from this equation, we can actually illustrate the position of the resultant vector, by which along the x direction, the magnitude is 15.1105, whereas along the y direction, the magnitude is 35.2606. So the resultant vector would look something like this. It makes sense lah sebab if A is in this direction and B is in this direction, the resultant R would be somewhere in between those two vectors. If I redraw the R vector in a planar direction, as in X and Y direction, we will have like a kind of an ideal triangle, you see. Sudut tepat dekat situ kan. You can actually calculate the magnitude of R dengan menggunakan persamaan segitiga ataupun the theorem Pythagoras equation, whereby R is equivalent to Rx squared plus Ry squared and then square root all those expression. So Rx and Ry are known. Masukkan je value tu dalam your equation and the resulting value would be 38.3619. What is the unit? Unit dia is Newton lah sebab force kan. All the magnitude are measured in force. So the unit is Newton. From this triangle, we can also calculate the angular direction of vector r. If we call the angle to be theta, so the relationship is tangent theta sama dengan tentangan, which is magnitude of ry, divided with sebelahan dia, which is magnitude rx. So rx is known, ry is known, so that's quite straightforward. Substitute all the values into your equation and you will get the corresponding theta to be 66.803 degrees. Okay, we're done. That is all for now. I hope you benefit a lot from this session. And don't forget to submit your e-attendance exercise as proof of your online participation. Anyway, it's a good practice for you as well lah. So, in the next lecture series, we are going to cover on the three-dimensional part of the force vector. That is even more interesting, dude. So, till then, see you later, alligator.